Pythagorean theorem is one of the best known algebra formulas, and if you ask most people who have been through high school or who are in high school, they will know what Pythagorean theorem is. Pythagorean theorem deals with right triangles. So you need to make sure you understand that Pythagorean theorem only works on right triangles. So I drew a right triangle here, and I'm going to show you the proof of Pythagorean theorem using jelly beans. And this is actually a very common standardized test question. So what I'm going to do is measure out the side of each triangle using jelly beans. So I'm getting 3 for this side right there. So I'm going to line those up. I'm going to use orange over here on this side. And I got 4 for this side, so I'll call this side 4, move them back. And then down this side, this is the longest side of a right triangle, and it has a name. It's called the hypotenuse. And that side should be more than 4. And looks like we should get about 5 on that side. So I'll slide that out of the way. So the sides of this this right triangle are 3, 4, and 5. Alright, I'm going to show you how Pythagorean theorem works. Most of you know that the formula for Pythagorean theorem is a squared plus b squared equals c squared. And that's the first most important thing, and we will obviously come back to that. A lot of times people will say a plus b equals c. And as you can see right here, if I added a and b together, I would not get c. If I added 3 plus 4, I would get 7. So a squared plus b squared equals c squared is the only formula that works. And I don't think I mentioned that a and b are the legs. The hypotenuse is always side c. All right, this says a squared. So what that literally means is that I need to square side a. So I am going to make a square out of side a. And I think I'm going to need to adjust this so you'll see it. If I make a square out of side A, that means each side needs to have 3 jelly beans. So I have 9 jelly beans, which makes sense because 3 squared is 9. So 3 squared is 9. And now I'm going to add side B. I need to make a square out of side B. So if I make a square out of this, since this side has 4, the other side have to have 4 as well. So I need to make a square out of side B. And I know you can do the math. If I make a square out of jelly beans over here, I should have 16 jelly beans. So this side was 4 squared, and that is 16. Now, if we look at what the formula says, we need to go over to side C and make a square out of this side. If I make a square out of this side, I should have a square that contains 25 jelly beans, so that each side has 5. I'm just going to pull them all over here and see how quickly I can arrange. I think I have them all there. They're actually not round, so they don't fit perfectly well together. See if we can smush them in a little bit. But over here in this square, I have c squared, which was 5 squared, and I made 25 jelly beans in that square. Now, what ends up happening is if I add together my orange and blue jelly beans, if I add these together, I'm going to make another row here, but then I can make another column over there. And what I end up with is a square of 25 jelly beans. And the reason is because 9 plus 16 is 20. So Pythagorean theorem works only if you square the sides, and the proof of it is right here. If I literally draw a square over here, let's see, I use blue. So I literally drew a square over here that was the blue jelly beans. I had a total of 9 jelly beans in this box. And I'm going to move the orange ones away. Over here, oops, can't come back, hold on. If I make a square out of this side, these were our orange jelly beans. And we had 16 jelly beans over there. And then if we move those out of the way, it's, oh, that was terrible. Sorry. These were the purple jelly beans. And I ended up with 25 jelly beans in there. So literally, if I added these two squares together, they would end up equaling that square in number, in size. Now I needed, if you remember what I did with the jelly beans, I had all of the 16 boxed in, and then the blue ones went around on two sides. So it doesn't necessarily, they're not the same color because I was showing you the two different sides, but you have to kind of cut this in strips to get it to fit in. But if we even think of something like carpet, if we took all of the carpet out of this room and all of the carpet out of this room, we'd have to piece it, but it would cover the carpet in that room. And that is the proof of Pythagorean theorem. Now, the way we used the problems, we would have a triangle, or maybe we were given two sides and asked to find the third side. So, for example, our formula is a squared plus b squared equals c squared. Let's say we knew that a was 3 and c was 9. So what we're looking for here is side b. So if we just use our formula, 3 squared plus b squared has to equal 9 squared. Well, 3 squared is 9. We know what b squared is. And 9 squared is 81. If I solve this problem, I need to subtract 9 from both sides. So I will get b squared equals 72. So then that means that b is going to be the square root of 72, which then I have to estimate. And if you've watched the estimating video, I know that the square root of 72 falls between 8 and 9. 8 would be the square root of 64. 9 would be the square root of 81. 8.5 is going to be the square root of those numbers multiplied, which is the number I'm looking for. So I can estimate side B to be about 8.5. And that is how we use the Pythagorean theorem.